All right. Hello, everyone. Welcome. Thank you so much for joining us today. Really excited for our presentation, but before we jump into that, do some quick introductions and go over a few other items here. All right. So my name's Kayla. I'm here representing the Acelab team, and we have Dave and Jason here from ATOS. So before I pass it over to them, I'm going to quickly take you over to Acelab. All right. Here we go. In just a moment, you should be able to see my screen. Here we are in Acelab. So if you're not already familiar, they're a great place to start when you're looking to do some materials research is this search bar at the top of the screen. So you'll see here we've got a few different options. You can toggle over to manufacturers in this case to find specific brands. However, you can also use our new AI search. That's a really quick and easy way to do some research. But in this case, here we are on ATOS's page. We've got some great information here for you. We've got Jason's contact information as well, video, as well as all of their products here for you to explore. So you can click into any one of these product pages to learn a little bit more about it. You can also click right here to save it to your firm library. That way you have it for future reference. But there's, yeah, lots of great information here on their page. So I'll send you all a link in just a moment so you can check this out. And something else I want to point out to you all, this is a new page that we've created here on Acelab. If you're looking to connect with any specific building product manufacturers, we've got this landing page here where you can book lunch and learns or meetings. A lot of these are AIA approved lunch and learns here. You can use this right here for ATOS and go ahead and book a office-wide lunch and learn for your team. I'll drop a link to this page as well in the chat. But a couple other housekeeping items to make note of before we start. This is an AIA-approved presentation, so we already collected your numbers upon registration, so you're probably already good to go there. However, if you're worried we didn't get your number, I will also put a form in the chat to fill out to make sure that you get credit for the session today. We will also be doing Q&A at the end of the presentation. So if at any point you have a question that comes up throughout the presentation, go ahead and drop that in the Q&A button that you see at the bottom of your screen, and we will get to as many as we can at the very end. And you will also see a poll pop up on your screen during the webinar. That is a great way to get some follow-up information after the webinar today. So it is optional if you're not looking to get any kind of email communication after the webinar, just click the X and we won't bother you. However, if you do want to get connected with Dave and Jason after the webinar, fill that out with any specific questions, information you're looking for, project specific information, and we will open a Acelab conversation after the webinar. So you'll get an email notification coming from a no reply Acelab email address. You can click the link through there to go directly to the conversation in Acelab, and then that's a great place to, again, get any kind of further questions answered or some additional information from them to their team directly. And then last but not least, we will also have a post-webinar survey. So we really appreciate any feedback that you may have for us. So feel free to leave that there at the very end. And with that being said, Dave, I'm going to go ahead and pass it over to you to get us started.
Okay. All right. Assuming my screen is still sharing, so we're going to be good there. Thank you, Kayla, and thank you, everybody, for joining us today. Again, my name is Dave Willard. I'm with ATAS. I'm the Midwest District Manager for ATAS, overseeing kind of the Midwest and Texas and Arizona. And today we're going to go through metal roofing, kind of a history of metal roofing material and some of the applications. Brief history about ATAS. ATAS actually stands for Aluminum Trims and Shapes, founded back in 1963 by the Buss family in Rochester, New York, onto our third generation owners now. Based in Allentown, Pennsylvania, we have 4 other manufacturing facilities in Allentown, Mesa, Arizona, University Park, Illinois, and Elkton, Maryland. We also have a sister company, Brightsmith Coil Coaters and Post Painters to help paint our stock. We've been doing this for well over 60 years and still family owned and maintains a family feel as far as the company goes. What we supply is everything from metal roofing systems to perforated metal panels, metal wall panels. You can see us. We cover most of the exterior cladding of buildings. We can also do curved and tapered panels and custom panels. Custom fabricated panels. We actually have a place right on our site for you to create a panel of your choosing, and we can help you to create it. Column covers, insulated metal panels. We do interior ceilings for sound control and acoustics, ceilings and soffits, perimeter edge metal, different types of edge metal cornice systems, architectural accents, pretty much anything you can think of that has to do with metal. We can do it. We have all the accessories, secondary framing items. So when you think of metal, if you're going to be putting metal on a building or thinking of metal, we'd like you to think of ATAS and reach out to see if we can help you. If we can't help you with it, I'm sure we can find somebody that will. We like to try to be a resource in that way. And one of the biggest resources we've just added to our repertoire is the purchase of Metalworks. We now own Metalworks is now an ATAS company, and they do heavy gauge aluminum and steel. They do plate 0.80 and up to 1/4 inch aluminum for very ornate specific designs. So we really do run the gamut for exterior cladding. So again, if you think of metal on the outside of a building, ATAS could be a match. Our online resources are pretty wide. We have spec assistants. We offer spec writing services on our website, submittal builders, tons of your basic and generic CAD details or just general CAD details, photo galleries for you to look at things. So we really do cover a gamut for what we do and how we do it. We also have different educational things. We have Did You Know series online to learn more about the products and what we do. So getting into the actual meat and potatoes of the presentation now, again, we're going to be talking about metal roofing, really the history of metal, kind of where it came from. We're talking about some of the materials that can be used in roofing in different and a few different applications. As Kayla mentioned, it is good for one unit for your AIA credits. So I'm sure we'll take care of that towards the end. So the learning objectives for today are pretty simple. We're going to try to observe and recognize the history of metal roofing and different types of metal used in the industry. We're going to talk about the manufacturing process and really the importance of the finish coatings and why the finish coatings are so important. We're going to describe the difference between low slope and steep slope roofing systems, and talk a little bit about the environmental benefits of using metal roofing or metal products in your building for sustainable reasons, the sustainable technology that's available, and different features of metal roofing. So the evolution of metal roofing goes way back, starts way back in history. It's always funny sometimes people will ask if this is a new technology. I actually did have somebody ask me, well, since is metal roofing new? And it's not. Back the Dome of the Rock in Jerusalem in 1970 was one of the earliest traces was actually in 970 BC was one of the earliest traces of using metal on a roof. The Catholic Cathedral of Cologne in Germany back in 1200 uses metal. The Kronborg Castle in the 1500s, and of course the Acelab Cathedral in Denmark also used copper on their roof. The Cologne Cathedral used lead on their roof way back in the 1500s. So it certainly by no means is new. It's been used widely throughout Europe. We all probably recognize this, St. Peter's Basilica in Rome, one of the largest, if not the largest church in the world, the first cornerstone laid by Pope Julius II. Now this used, obviously a metal roof. Now that the technology has changed a lot over the years for using metal and using different types of metal on roofs, but the main idea is the same. We're looking for function, such as keeping the water out, weather tightness. We want it to look nice, so aesthetics are good. And then, of course, in today's world, those buzzwords of sustainability and resiliency is what comes to mind. So today's technology has definitely helped advance the use of metal in metal roofing technology. America's got its own history with using metal roofs. Thomas Jefferson's Monticello Estate, if you've ever been there, you'd recognize that look. Andrew Jackson's Hermitage, Ulysses S. Grant home as well incorporated a metal roof in the old Christ Church in Philadelphia, PA. So metal roofing is definitely ingrained in America's history. Where was the first roll forming mill? Back in 1801, at the age of 65, Paul Revere, the same Paul Revere that wrote all over, yelling about the redcoats are coming, established the first copper rolling mill in Massachusetts. The first order was for over 7,500 pounds of copper sheathing for the Boston State House. Now, an interesting fact about the Revere copper mill is that he actually sent his son to England and over to Europe to actually steal some of the designs and some of the technology for that rolling system that had already been popularized in Europe. So it was kind of a fun thing for his son to do, is go back there, remember it all, and bring it back and put it into use. The oldest aluminum roof in America is on the top of the Washington Monument. I'm sure you recognize that site, but there's when it was originally set in place in 1884, it was 100 ounces. It was the largest single piece of cast aluminum at the time, and it was placed on the structure. Now, when the monument was repointed back in 2010, the only area that did not need any repairs was what was directly under that aluminum cap. Now, of course, believe it or not, that cap is not quite 100 ounces anymore based on lightning strikes that it took over the years. And a little fun piece of trivia about that 100-ounce cap, it was actually in Tiffany's for a while before they placed it, and people had the pleasure of being able to walk over the top of the Washington Monument, knowing that that piece was going to be put in place shortly. Now, here's some misconceptions of metal. Sometimes when people think of metal for buildings and houses or roofing, this is what they think of. This is that common perception of a kind of a pole barn or a barn building, and not very attractive, could be loud. But although this is not an aesthetically pleasing looking building, this roof was in place for over 100 years, and when it was replaced, it was really just replaced for aesthetics. It was still doing what its primary intent was, which was to keep the building dry, even though it wasn't aesthetically pleasing. So the resiliency of these metal roofs is really where they shine. Now, today we talked about the advancements in metallurgy and paint chemistry. They allow for steel materials to be used in high-end architectural applications. Like you can see on this roof, is by looking at it, you might not immediately think that's metal, but that's exactly what it is. So these advances have really helped move that industry along. So let's get into the science of how this metal works and the different metals that are involved. So your basic base metals that we talk about when we talk about the base is what's the substrate, or what's the what's the substrate of the material being used. Obviously, aluminum is widely used now because it's corrosion resistant, so you don't have to worry about corrosion. It's great for coastal environments where there's going to be sea salt. We'll talk about that a little bit further down in the presentation. Its resistance to other corrosive environments makes aluminum a great choice. Now, steel obviously was initially used for its function as an integral part of the building structure. So it was more of a structural idea, having a high strength to weight ratio. And then, of course, we have the natural metals that are used today quite a bit, copper and zinc, for example, which have been time proven for their corrosion resistance as well. As far as the fabrication process of steel, aluminum, or copper or zinc, or the natural metals, they have evolved into the architectural market. Now, both steel and aluminum are formed on similar machinery, but the forming properties might vary depending on what panel you're using, what profile, and what gauge of material you're using. So some things have to be considered before we move forward. Of course, that material selection may be dependent on the panel and actually in the geography or the geographic location of the building. The history of aluminum got to start back with back in the 1800s. Jules Verne actually described an aluminum rocket ship in his book From Earth to the Moon. In 1886, Oberlin College student Charles Hall and a French engineer simultaneously developed an inexpensive electrolysis process for aluminum, which was patented in 1889. And then, of course, in 1959, Coors Brewing company popularized the two-piece aluminum cans with the pop-top lid and established a cash payment for recycling cans. So that all started in the late mid 1900s. As far as aluminum goes, 65% of all aluminum processed or produced over the last several years is still in use today. We know aluminum is lightweight. It's very flexible and pliable. And of course, the different finishes is really what makes it attractive for an architectural or for an aesthetic reason. Aluminum can be recycled over and over with no loss of its physical properties, and recycling uses only 5% of the energy required to produce primary aluminum. So it's a lot less expensive to just keep recycling the same aluminum over and over and over again. For marine environments, we know that if you're within a mile of a seacoast or from an ocean or any saltwater body, we know aluminum is extremely acceptable and the one that should be used. Galvanized or galvalume, not necessarily recommended because of the corrosion of the sea salt. Now, if you get more than a mile away, you can use whichever one you think is acceptable or which one you like. This map just kind of shows where those where that high chlorine ion deposits are going to be. And of course, it's all in those coastal environments. And if you can see, Florida is a hotbed for it. So anywhere you're along the coast, typically within a mile of the coast, at least you want to use that aluminum. We know aluminum is more resilient to salt spray. And these are just some of the stats that kind of prove that. Aluminum has a 400% more salt corrosion resistance than steel or galvanized steel. So it does pose a better work life than steel in those coastal environments. Now, initially, steel was used for function, not necessarily aesthetics. It was easy to put up. These huts were put up all over, during wartime because those the steel could be integral to the design of the building. So you could have less structure, and the panel was actually doing a lot of that holding for you. So it was quick to erect, quick to get up, quick installation and assembly with minimal framing. Now, there are metallic coatings now used in steel all throughout the construction industry, and it's used to enhance the corrosion resistance of steel because people still like steel for that high, weight to strength ratio. So the first thing is to just do zinc, which is galvanized. And zinc is just a sacrificial element that they can coat steel with. So it does get a scratch or a scar on it. That zinc will sacrifice itself and fill in the scar. Of course, once the zinc is used up, it'll rust. So when you think galvanized, I think of the guardrails on the highway, that kind of speckled, flecky galvanized. And then the next thing they can do is an aluminum and zinc combination. Now, this combination of alloys offers both a sacrificial element in using the zinc, but barrier protection is well added to the steel in the aluminum part. And this, you'll know the term galvalume is what you'll hear in the industry, or zincalume or galfan. Different industry terms, but in this case with galvalume, you have a barrier protection of the aluminum and then the sacrificial element of zinc to fill in the scar or the mark. And we have just a quick look at how this works for the hot dipped galvanized that you think about. It goes through obviously a cleaning process, and then the biggest part is it goes through a pot with that liquid coating metal. There's air knives that keep the consistency in the thickness, so you get the right thickness, and then it goes through a passivization process, which is just really an oil that's added to protect the coil while it's being transported. And here's a look at that coming out of that metallic coating actually being applied as it's being pulled up through that bath, right under those that FO and Demco are the knives to make sure it's the proper thickness, and then you see the nice clean sheet coming out at the top. Now, the mechanism of corrosion for galvanized steel is you get a scratch, it gets down to the surface, and then that zinc coating will heal itself. We call it a self-healing zinc coating, but it is a sacrificial element, so it doesn't last forever. There's different coatings. I'm sure you've heard of AZ50 and AZ55. That's really just measuring the weight and the amount of zinc that's applied to that steel substrate. it does require, a certain amount of technique to be able to do it. And that process was developed by Bethlehem Steel in 1992 to make this aluminum and zinc alloy coating, which does combine barrier protection with aluminum protection. And as far as outdoor exposure goes, in the rural areas and in different industrial areas where you have galvalume, you can see it last quite a while longer until you get that red rust, as compared to just in blue where you just have the bare hot tipped galvanized. So the galvalume has made a huge difference when using steel. And here's kind of how it kind of works with galvanized. If you do have a painted or a coating, once that galvanized or that zinc goes away, you can get that edge creep and paint peeling because there's nothing now holding the paint on. Where with galvalume, you have the combination of an aluminum barrier and then the zinc in there as well, so you don't lose any of that form of the steel. You don't get the edge creep. You get an initial red rust on the edge of the cut, which is perfectly acceptable and fine, but that's where it stops. So galvalume obviously has changed things as far as being able to use steel in different environments once it's coated properly. Here's just an example of what different things look like in salt chambers. You can see on the left, that's just galvanized steel in a salt chamber, and you can see how more deteriorated that looks, and the edge creep in the paint actually peeling from the edges, and then aluminum obviously with no problems whatsoever. So the coating process, and when we talk about coating, we're talking about painting in different finishes. And that coating process for aluminum as a substrate really is composed of 8 layers, each developed to increase the corrosion resistance of the panel. So the first thing they do, which might be hard to read on your screen, but they do a chromium oxide pre-treatment, and the pre-treatment is critical to treat the substrate to get it ready to hold on the primer. They do final chrome rinse, then they have a primer, and then of course a high coat, the top coat, which is a high performance top coat, which we talk about as PVDF paint or paint finish. The underside is the same process, except instead of a finish coat of paint, it has a wash coat. So really 8 layers go onto that piece of aluminum to give it its final look. For steel, kind of the same idea, but there's an extra step that's involved, and that's that aluminum zinc coating that goes on. Then they go ahead and wash it, clean it, and paint it. So as opposed to 8 layers, you got 10 layers because you have to have that AZ aluminum zinc coating. Now, the pre-treatment methods is really what makes all the difference in the world, because we need to be able to make sure that everything that goes on there stays. So traditional chromium conversion wet chemistry is the best, where you're actually cleaning it in a wet chromium bath. And pre-treatments are critically important when it comes to getting that substrate ready to take on a top coat. It improves the surface reactivity, promotes paint adhesion, and provides the enhanced corrosion resistance. So all these things are critically important when it comes to your paint finish. And then, of course, you have the paint itself. Now, the paint nowadays, the technology has changed a lot. Its resistance to ultraviolet properties, which keeps its color longer and retains its gloss and color. It's outstanding resistance to dirt and environmental aging. It's virtually maintenance free when you talk about the PVDF paint finishes, non-staining, and tested and proven by over 40 plus years in the field. And most companies now are doing 30, 35 years paint finish warranties when we talk about PVDF. And in this graph on the left, 54%, that big green part, is really just the solvents that are carrying the paint. 28% is the resins, and 70% of those resins are PVDF. And then 18% is the pigments. And that pigment technology has changed, and we'll talk a little bit more about that in a few minutes. Now, these are Florida tested. Now, Florida is probably the best place to test for real life exposure. I said it's this kind of synergistic effect of UV, moisture, and heat that makes that southern tip of Florida ideal. And that's just a shot of the field that just has real paint finishes out in the Florida sun for 20, 30, 40 years. So we have real world testing. And here's this is kind of a nice example I think is really cool. These have been out since 1967. And of course, this picture was from 2014. So this was close to 40 years or so of paint exposure. And the very top closest to the numbers is what's unexposed. So that's covered. It doesn't see the sunlight. And the main body of it is exposed. And as you can see, even since 1967 and 73, not a lot of changes in those colors. And now the paint technology is advanced even further than what was painted on there 40 years ago. There are other coatings that are available in the coating industry. Siliconized modified polyester. It's used for post frames, pole buildings. We have siliconized polyester, plastisol, acrylic, and they have different uses. And of course, PVDF is the top quality, the top quality finish. The other coatings are good, but they need to be used in certain places in certain applications. So you have to be aware of where you're using them and what you're getting when you buy them. And that's where the MCA, the Metal Construction Association, they've come out and they work with all the top, metal manufacturers throughout the country. And what they've tried to do is create a level playing field for all the different warranty claims that are out there. Because sometimes you can have a lower quality paint and it'll have a longer warranty. And they have very aggressive warranties, but those warranties might be allowing a greater fade variation over time. So you might get a 40-year warranty on something, but it says it's a warranty that allows a certain amount of fade. So you have to be careful that, what your warranty is giving you isn't going to give you a different color in the next 10, 20, or 30 years because they allow that. So the MCA is trying to clean up warranty claims. And how they've been doing that is by using real-time testing for the PVDF systems and real-time testing for the different siliconized and modified polyester. They're trying to make it so that you don't have to beware every time you're looking at a warranty. They're trying to clean that up. The MCA monitors the weather effects on paint, like the color change, fading, and gloss loss. They look at cracking, peeling, and chalking. If you can remember, paint finishes sometimes will have that chalking and blistering. Why does that happen and what causes it? They look at moisture sensitivity. They look at biodegradation, including mold, mildew, and fungus. So they really look at a lot of different areas to make sure that everybody is kind of using the same methods and measures to measure their warranties and not just what makes sense to them in small print. Now, everything starts with metal coils. Now, as you can see, those coils in there are pretty big. They can, 10, 20, 30 pounds a piece, 2,000 linear feet, 3,000 linear feet of coil per coil. Everything comes out of a coil, which kind of surprised me when I started. I mean, everything comes out of the coils. But the size of these master coils is something we have to look at because we paint the whole coil. The whole coil has to be painted for a project, which is why sometimes the cost of custom colors is a bit expensive because we do have to paint that entire coil in the coil coating process, which we'll talk about. So for small runs, coil coating sometimes becomes fairly expensive. So just stopping at coil coating for a second. Excuse me. What do we mean when we say coil coating? Well, this means the coils are painted prior to forming into whatever shape or design you want. So the coil or paint is applied or roll coated all at one time. Technology is really advanced in this process. They have inline cleaning, inline pre-treatment, primer, and color coat. It's a continuous process, which allows for an even film thickness and very consistent product. There's a lot of quality controls in place, and this is why this offers the longest warranties available is on coil coated products, because everything is very much controlled and monitored throughout the whole process. The machining and the mechanism to actually coil coat is quite extensive. I mean, this is just a obviously a sketch of what a coil coating machine would look like, but these can be as many as 3 to 4 football fields long. They can be as many as 2 to 3 stories tall to accumulate coil, so that can continue to run. Down in the beginning on the far right of this, where it has payoff at the far end, that's where they actually can splice coils together so that this machine never has to stop running. It can continue to run. They can change gauges in between. Then they change the paint during the paint and finish coating section. So these are very obviously long runs, but the idea is to just keep it moving and continue to run that 2,200 or 2,000 or 3,000 linear feet of metal through the machine without shutting everything off. So it's why big square footages are needed for if you're talking about like custom colors or anything of that nature, because we are going to paint that entire coil. Now, post painting is a viable option when it's necessary. Its advantages is it is a good coating system, and it's good for small batches because what we're going to do is actually form the panel first, then paint it. The disadvantages, it is what it sounds like. It is post coating, so you're kind of painting it after the fact. So quality sometimes is hard to control, and the warranties are a little bit more limited when it comes to a post paint product. And usually it's a lot of times that's used with aluminum extrusions to paint door frame windows, accessories for roofs and wall applications. But post painting is an option from time to time if it's called for in that manner. Now, factory formed components, and we're going to talk about factory formed because that's a big buzzword that we see here a lot. But the manufacturing process starts with your raw material, your coil, and it's slit down to what size you need. So that coil has to be kind of taken off the master coil. It's leveled and cut to length for each particular project. Now the leveling, where it says flattening, straightening, precision leveling, that's the part that really separates on-site kind of roll forming and manufacturing to factory manufacturing, because those that machining needed to flatten, straighten, and precision level is very large, it's very heavy, and it's very expensive. And a lot of the on-site formers just don't have the ability or capabilities to do those things. And as we know, metal has memory, so you need to be able to line level different things. And here's an example of what a precision leveler looks like. So you can see the size of that machine. It corrects the metal as it comes out. So if there's a bow in it or a curve, or if it's slightly off on the edges and you have edge curve, but just think of when you take a piece of paper, if you roll it up into a tube and you set it on your desk, it stays in that tube form. It'll hold that memory. When you try to flatten it out, it still wants to stay curved. This machine helps take the curve and all those inconsistency out of the metal as it's being unwound off the coil. And again, large machine, which is very difficult to emulate in the field. And these are two smaller ones, but still weight and size extremely large. And these things are bolted to the ground, and they're used to take the edge wave and really straighten out that piece of metal or steel before it's roll formed into a project. Our a lot of times our owner says it doesn't do anything to help the metal. It just gives a much better product. You have a much better product at the end of the day when you have precision line leveled everything as you move forward. We can also use different folding machines to fold panels and the products that you want to have. Obviously, roll forming machines are. One thing with factory folding or when we use these types of machines is lengths are limited. You could be limited to 15, 20, or 26 feet long for different items. So folding process is good, but it does have some limitations. Roll forming, obviously you can just continue to roll as long as you want. And we jokingly say we can run panels as long as a truck can carry them. Although there's other limitations as far as how long you want to have a panel, but there's roll forming equipment is quite large. And then this is you can do combination of roll forming and press forming. And this on the far right is this material comes in, it is roll formed through all those different stations. And then when it gets to where this yellow gate is, that is actually stamped then down to give it a shape. So we're talking about roll forming and press forming together. This will form like a scalloped shape type of roof. Of course, there are other special manufacturing capabilities. The metal doesn't just have to be straight. We can curve it. It can be convex to give you a nice eyebrow shape. It can be concave. We can do custom pre-notching and a lot of fun different things we can do with the metal. So there's a lot of different design considerations when it comes to these things, but the panel doesn't necessarily have to be straight or smooth. We can curve it, perforate it, vent it, and do a lot of fun things. As in this silo kind of look here, we can actually do different tapers and do tapers with panels. The panels can be embossed. We can have stiffening ribs, striations. Again, really up to your imagination when you talk to your rep as far as what can you do or what do you want to do. Some domes that are really special because they're usually looms. They have different shapes. We have a lot of technical stuff goes into making these types of panels, but it's all possible. And of course, different manufacturing capabilities between water control items just to finish up the product, scuppers and gutters, downspouts, all the things you need to finish a project to complement the rest of the building. So who's using metal now? Well, metal is one of the more widely used, building materials, especially for skinning, because of all the different unique things you can do with it. So here's a U-Haul using different painted wood grain looks to present the outside of their building. This is a private residence, Allentown, Pennsylvania, using a metal for their roof, of course. And then different looks at different buildings that you can attain with whatever your imagine might be. A building utilizing green space and metal walls on the roof. That might be a living roof. A fun building in Ithaca, New York, using a 15-inch diamond shaped panel to kind of create a look up. I know that looks like a mock-up or a rendering, but that is actually what that's a real picture of that building. It's fantastic. Now, when we talk about what it takes to have a successful roof project, it comes down to how many questions we can ask and what is our design intent. So the first thing we look at is we want to evaluate the roof design. We want to consider what's the right panel for the design and select the right roof product. Sometimes what we have in our heads and what we want to use might not be appropriate for that application. So we have to select the right appropriate roofing product. Then, of course, when it comes to installation, we want to make sure we've used time-proven flashings and trims, potentially sealants in critical areas, although if things are properly flashed, sealants are ending up being a maintenance issue. So we like to have everything be nice and flashed properly. We talk about proper clip placement for parade adhesion and appropriate fasteners and other accessories. So there's a lot that goes into that installation part of it. You can have the best, as I say sometimes, you can have the best ingredients in the world, freshest fruits and vegetables and freshest meat products, but if you don't know how to cook, you may not have a good meal. So you can have the best product in the world, but you still need to have the right installer and installation practices work. And then, of course, for maintenance, proper design and installation will really minimize that maintenance concern over the lifetime of a roof. So really, there's a lot of things that come into play. There is all the different product testing on most of these things, from fire resistance to impact resistance, different certifications for different approved buildings. There's site-specific evaluations that come into play. I know Florida has a lot of fun codes that they use, and we actually have whole AIA presentations that really speak to these different testing and these different results. If you need more information, if you have questions on these, I'm sure we have the answers. They're very project specific. Different uplift testing that gets involved. ASTM E1592 is a big one for metal roofing, and then of course the different UL testing that they have. Again, there's a lot of uplift testings for metal roof that's going on, and we do have an AIA that speaks to those tests and that uplift performance, how they work and how they test. It's actually a fun presentation. Of course, water and air infiltration is a big one that we have to work through. So they have those different testings, E331 and E283. I'm sure everybody out there can do full-on presentations and dissertations on these different ASTM testings that are out there. Rate of air leakage, determine the rate of air leakage through exterior walls and curtain walls, water penetration on the exterior of metal roofs. I'm sure you are very versed in all these different test methods. But we have all that available for you. So as far as roofs go, there's really two different types of panel systems. You've probably heard functional and architectural, in that originally roofs were really just functional or architectural. They were either steel, part of the building envelope, going to help hold the structure, or they're architectural. They were pretty and they weren't very structural. So functional, really structural; architectural, pretty, but not very functional or not very structural. Well, now with the changes in technology and what we're doing, now there's kind of a hybrid where panels can be functional and architectural. But the two biggest things you have to decide is it a low slope application, or is it going to be what we call hydrostatic, where there could be potential ponding and you really got to have a watertight product up there, or is it hydrokinetic, steep slope, where it's just a watershed, where water is just going to shed right off the edge and it's not going to stop and stay in one place. So remember, early on, there were really just those two terms, functional or architectural. And now we have that hybrid where you can do both, which is even more important to understand the product design and what you're going after and what the building looks like, and even geographically, where is this building located or where is the project located, so we can make the right determination of, do you need hydrostatic, low slope, or hydrokinetic. And typically we talk about low slope being about 1/2 to 2 inches, 2 on 12, to steep slope being 2 on 12 or greater. I know low slope they also will consider 1/4, but with the way things settle, I think once you start getting down to 1/4 on 12, that's pretty much a flat roof. So, but steep slope is typically 2 on 12 or greater. A couple different clips for steep slope roofing. First one there, on the left is an integral lock, which pretty much just means the lock is at the base. The clip holds the panel on at the base, so there's very little friction, so that panel is allowed to slide back and forth with thermal expansion and contraction. The one on the right, a friction fit. The clip, as you can see, goes all the way up to the top of the leg on the panel. So there's a lot more friction that's going to be allowed, so that thermal expansion and contraction might not be as great or as easy as you'd like it to be. Now with both of these, they're usually pinned at the ridge, and then the panel is allowed to expand and contract toward the eave of the panel. So that's kind of just an example of how those clips float. So the clip is attached and the panels just kind of float, and they're allowed to expand and contract up and down the building, which accommodates for long panel runs, 40, 50, 60 feet long. I mean, we've run panels as long as, 90 feet. So let's see here. For a low slope seam or hydrostatic seam, this is one where the clip is attached, but now the clip is actually becomes an integral part. There's usually a 2-piece clip, which allows that expansion and contraction, but now the seam is actually pulled together with or seamed together with a big machine that just goes over this seam and just seals everything together. So now you have a watertight seal, which you'll need, because typically on 2 on 12 or less, you're going to have more water. You could have the potential of water ponding. So you want to make sure that you have a good seal at the top. So there's also a T type of clip for insulated metal panels. So you can do an insulated metal roof panel, which has obviously the clip hidden as well. It's thermally broken. And with this is a T-type design. So the panel comes together to form a T. Typically, you're going to put a non-skinning butyl at that joint where that red batten cap is. And then again, you're going to have a machine come by and seal that whole top batten cap onto the panel, so you can have a completely sealed arrangement, but it's still, because there's a floating clip, will allow for some thermal expansion and contraction. And these can be used as down to a minimum slope of half on 12. And again, now this is an insulated metal panel, so you have steel on both sides with a polyisocyanide core, which can give you about an 8 R value per inch. So a 6-inch panel essentially can get you about a 48 R48 for a roof panel. So, and now your roof is done, you're dried in, and you have a nice clean look at the bottom if you're over purlins, and the top just looks like a nice standing seam roof. Oh, I can close that. So some environmental benefits when it comes to different standing seam roofs that we can kind of make you aware of is, once I get this to advance, there we go. A bunch of different things. We can talk about energy efficiency, water control, which we'll talk about a little bit here towards when we get to the end here. Cool pigment technology in the paint. We're going to talk about ASV shims, above sheathing ventilation, and of course the recycled material from beginning to end, you know, and the fire resistance idea. So there's a lot of good benefits that go with using the metal. They are energy efficient. They can be recycled. Metal is a great to apply cool roof principles, and we're going to talk about those in just a second. The first one is an ASV shim, or an above sheathing ventilation shim. And what this does is your clip sits on this, which is going to give you an offset or a gap between the panel and the roof deck. And this can promote that heat to go up and then out of a vented ridge. So it allows you to kind of cool that roof naturally. As it shows here, cool air can flow in, hot air flows out, and it creates that airspace between the roof deck and the metal panel. They've done studies, and they said that a painted metal with a 4-inch airspace will have attic temperatures that do not exceed the peak outdoor air temperature. Now, I don't think you're going to get a 4-inch airspace in reality, but we know that even an airspace of 3/8 of an inch can drastically change that dynamic. And it also acts as an insulator in the winter months when it's cold, because you have that extra layer of the extra air in between the panel and the roof. So it actually acts as an extra insulation layer in winter months. And they all are also thermally broken in that roof assembly, the shims are. So ASV shims, and we do have a presentation on that, talking about the perfect roof and how to design that. So you have using that metal panel as a cool roof technology, and reduces that, as it says here, with metal panels, you have a combination of solar reflectance, which we're going to touch on in a minute, and thermal emittance, which determines the temperature of the roof and its ability to be cool. We can reduce energy usage, and it does help decrease that heat island effect, because there's no it doesn't hold on to that heat like an asphalt or other types of building materials might hold the heat for a while. And of course, it's eco-friendly. It doesn't outgas the way petroleum-based roofing materials do. So a lot of positives when it comes to using a metal roof. And talking about that reflectance and emittance, it's pretty simple. Reflectance is obviously what gets shot back up into outer space, and then emittance is what it holds and then eventually will let go of. So you want something with high reflectance, which is going to be highly reflective in the pigments. And then of course you want something that's going to emit quickly. It's not going to hold onto that heat. And if you think of like a cast iron pan, when you're cooking, a cast iron pan is going to hold its heat for a long time, where an aluminum pan, you can fry eggs and bacon, and within minutes it could be back down to cool or touchable. So that thermal emittance is important. And that's how we come up with the SRI, which I'm sure you've seen on different paint specifications that you've worked on. What's the solar reflectant index of a certain paint or a certain material, and that's actually measured by its ability to reject solar heat, as shown by a small temperature rise. And then of course it's shown they start with standard black. It has a reflectance of 0.05 and emittance of 0.90. They consider that 0. And then white has the highest reflectance of 0.8 and an emittance of 0.9, which is then what they consider 100. Every other color falls in between that. And we do have the calculations, and I think most manufacturers show that color, what that color does. But materials with the highest SRI value are the coolest choices for roofs. And of course, with today's technology, if you were using, say, blue back in the 1980s or back in the 80s or back in the 90s, that blue, because of today's technologies, might be a cooler and have a cooler SRI number than it did back then, because the pigments are changing so drastically that they don't absorb that heat as much. Now, the benefits of solar ready. Now, this doesn't mean the panels can be solar collectors. It just means a standing seam metal roof can easily be ready to handle solar panels or different type of solar systems you might need, mainly because we can clip right onto the seams, right onto the legs of the panel, right onto the seam. So it's an easy installation. You're not poking holes in the roof. And if you think about it, rule one for a roof should be don't poke holes in it. So when it's on a standing seam, it's an easy installation with different types of clips and brackets that can sit right on the top of the metal panel and get it off the roof so you can use it. So it's great when it comes to, like, for example, here, these crystalline solar panels shown on a standing seam metal roof. They can just hook right onto the legs and you're ready to go. As far as water efficiency goes with metal roofs, this is a great thing, especially when it comes to irrigating or harvesting rainwater, because you can capture the rainwater off of a roof pretty easily. And unlike in asphalt or other type of building materials, you don't have the worry of what's going to be in that water after it comes off an asphalt roof. It'll just be clean water that comes off, and 1 inch of rain on a square foot of roof could equal 0.623 gallons of captured water. So, 1 inch of rain on 1 square foot could give you just over half a gallon of water. So if you're looking for irrigation or brown water, this is one way to do it. And this can qualify for up to 8 LEED points in water efficiency for outdoor water use. And here's kind of a cool picture of that water assembly and use. And one question I got before is, and I'll answer it now, is we do not provide the container to collect the water. We can provide all the other stuff, but you're going to have to get your own cistern or bucket to collect the water. And then, of course, as far as LEED goes, and we do have people within our company, and I'm sure everybody does, that can help figure out what LEED credits might be available to you in different applications. But there are tons for integrative process categories, sustainable categories. There's several points that can be gained there. Water efficiency, like we said, up to eight credits there for outdoor water reduction and indoor water use reduction. Energy and atmospheric categories, potential of 18 points for LEED in that. And then, of course, materials and resource categories. So if you are, designing towards LEED or with LEED in mind, that's something that we and probably other manufacturers can help with as well. But it is something that metal definitely can speak to, depending on what your design intent is. So with that, I've come to the end. So I appreciate everybody listening. I hope everybody was listening. It's always kind of intriguing to do these types of presentations where I don't see or hear the interaction. So I hope it was time well spent. And if you do have any other questions for us or have anything, I'm sure you know how to reach us. There's our information on the screen. And at this point, I guess Kayla potentially will take over and we can do maybe some questions if there were some. And I got Jason Richter on as well to help facilitate any of that. So Kayla, I guess you can take over. I can stop sharing, I guess, at this point.
Yeah, it's okay. You can just leave it up on this so people can see the phone number and everything. Awesome. Well, thank you so much for that. I think that was a really thorough presentation, and it actually doesn't seem like there's any questions so far. So folks, if you have any, now's the time, or feel free to leave them in the post-webinar survey. And yeah, I guess you did a really good job, Dave, because we don't have any questions at the moment. So would you like to kind of dig into any other specific areas or leave us with any other final notes before we wrap it up today?
I don't know, Jason, I don't know if you wanted to take 2 minutes. Jason's our architectural development manager. He is highly in with the architects. So that's what he does. So maybe Jason, if you just want to introduce yourself quick, because I know you're a resource that architects always go to. So
Sure.
Jason, if you want to introduce yourself.
Yeah, thanks, Dave. So like Dave said, I do have an architectural background. I practiced for a few years. I've been in the manufacturing world for roughly 20 now. So answer to all this is I understand a lot of the pain points you deal with. I'm happy to help you work through those in the best way possible. Beyond that, I am the main point of contact on Acelab. So if you do initiate a conversation on the dashboard there, I'll be the guy you're talking to. We don't use AI chatbots or anything like that. So talking to somebody who's got some deep product knowledge, happy to get into the weeds, as they say, with you on any kind of projects you're talking about, be it metal roofing, metal walls, so on and so forth. So again, thanks everyone for your time today. Really appreciate it, and have a great afternoon.
Yeah, thank you so much, Jason.
Yeah, thank you.
We actually had one question come in real quick, if you guys don't mind.
Yeah.
Looks like somebody's asking, we actually have two that came in. So we have someone asking about, they're saying, what about moisture ventilation below the metal roof?
So moisture ventilation. So a lot of times in metal roofing and most roofing nowadays, you are looking at vapor permeable roofing membranes where vapor is escaping through the roof substrate and assembly. That's where those above eaving ventilation shims really come into play. So having a vented eave, a vented ridge, and using those ASV shims is the best way to take care of moisture underneath the metal panels.
Perfect. Okay. And our next question is, how do you address wildfire mitigation on the ventilation space in the roof? How are embers prevented from getting into that space?
So again, this is an assembly that's weather tight, so embers aren't going to get into underneath the metal panels. The only real guidance we have in terms of this is California building code, which is now requiring not only non-combustible roofing materials for at least the exterior roofing surface. So you're talking about tiles, stone, and metal pretty much being your only options now in California. Beyond that, California has also required a 1-inch airspace between the outer surface and the substrate to mitigate the heat transfer of embers that do land on top of the metal roof or the stone roof, and could theoretically transfer that heat to the substrate to the point that it could start to smolder and eventually catch on fire. So that's the only real guidance we have in terms of building code. It's definitely a sensible reference point. I don't know if I'm sure they've done some testing to determine 1-inch gives you a factor of safety that meets their desired outcome. But beyond that, you could also look at insulated metal roofing panels. Those are one of the better options out there, especially on a commercial grade application where you have open framing and things like that. Those can also be fire rated roof assemblies.
Awesome. That's perfect. All right. And we do have a couple more, but I think since we only have a minute left, I want to be mindful of everyone's time. So we can go ahead and wrap it up. And if you had any unanswered questions, we'll be able to get back to you over email afterwards. Dave and Jason will send you all the questions afterwards as well.
Perfect.
Yeah, I think that wraps us up. So Dave and Jason, thank you so much for your time today. And thank you everyone who joined us. Again, if you filled out that poll, we're going to connect you via an Acelab conversation with Dave and Jason. So keep an eye on your inbox for that email. It's going to come from a no reply Acelab email address. You can reply to it still, or you can just log into your Acelab account and respond to any conversations there. So yeah, thank you again, everyone. We hope you all enjoy the rest of your day.
Thank you very much. Appreciate it.
Thank you.
Thank you.